Hi everyone, and in this submission I would like to make you understand how a program really runs and is dependent on the operating system. That is by required was to write, test and then debug a program in the language of my choice. In this case I used Python, and I then listed the services that I suspect the operating system to provide for the execution of my program. That is by observing the quantitative and qualitative result, and also then looking at the performance, maybe when it comes to replicating this experiment somewhere else or in a different machine. And now maybe let's get into the workarounds of the program, and I show you how that is varying. So I open this program in Visual Studio Code because I wrote it in two different phases. You run it using a command line, that is in a terminal, or you can run it using a graphical user interface, as I will show you. So the way this program flows is like this. This program really allows a user to add a list of items, that is the to-dos that he will have to do by the end of the day, can edit them or delete them, or can view what is already there, and then that is what it does in command line and also in graphical user interface. So let me first open this command line interface program and I show how it flows. By that, the way I run it, I press command shift or shift control and P, and then I say select interpreter. Trying to make this a 10 minutes video because this program is really doing that. So I open, I did that by saying terminal, then new terminal, then it is able to show up here where I can run my program. But I first have to move into where the file that runs this program is, that is in the to-do CLI, and then I say Python, then I have a main Python file. I also have this to-dos.txt file where my to-dos are getting stored once I write them here. So Python, then main.py, where the user can see maybe what to-do items are already there. A user can add items. Maybe I say I want to play chess, playing chess, can edit maybe number 3 or number 1, which is reading, and then I put eating. Maybe I can show what is there, and maybe I can delete number 4. So that's what the program does. And now let me go deep into, you can see that I can interrupt this program by saying quit, which is a property that I will explain because it's among the properties like interrupt handling. So let me first close this, and then I show what the program does. So we have these files here where I created the main, then to-dos.txt file, and then functions.py. And the main, let me not open it that side. I will go explaining the resources that the operating system provides. Here I have the first resource as input or output management, whereby the user has to type in something and then it is output on the terminal really. So he says add, and then can add a to-do item, and also he can say show, and then the output on the terminal prompts. And that's the first resource. The next resource is file management, where the files are created when they are not there, where to store those different lines that the user is typing on the terminal. You saw this to-dos.txt file. That is a file that creates itself, or when it's non-existent and you run this program, it will create itself Then those are the functions I will have to show you for creating that file, because they are separate since I used that way of doing it. And then another resource is the system calls and then the interrupt handling, where you saw me terminating the program with a quit. And then I can show you the functions.py, which also lists the resources that the operating system provides. File management, I've already seen that. Error handling, that is where the file is not existing, the operating system might throw errors to alert the user, but in this case I'm putting this exception that whenever this error occurs, then type in this to the user so that they can understand what is happening really. There is also another resource for file management and error handling, like I saw these errors. There is also another error that we shall see down. I have another resource at CPU and memory, that is if you create a list of items or a list of to-dos, that is a virtual object that the operating system has, or the CPU has to keep, the operating system has to keep in the RAM. So you can see that this resource is provided by the operating system, and then later on what it kept inside the RAM is written to the to the files. So another thing is security and then access control. You can see that I had a separate virtual environment whereby I can install all my libraries I need to use for these applications. For example, you see the graphical user interface where I used Streamlit. That was installed inside the environment so that it doesn't affect the outside, the system-wide operating system. That is security and access control. Then process management. You can see that at the real time of executing this program, it keeps a process that has to keep on prompting the user to see if maybe we reach an extent and we say we have to delete number, this item number 5, and for the user types in -5, which is not existent in the list. So it will tell you something like this, but the program continues. That's a process that enables you to do that. It also gives another resource, which is buffering and caching. Buffering and caching, that is, you see that the operating system automatically creates a space to handle these lists. You don't specify anywhere that I have these megabytes, so that is buffering and caching. And since I'm time bad, let me explain the graphical user interface. So that is, I can run the graphical user interface that has this file where I have the security and access control for these libraries I imported in this virtual environment, and then also I will explain how it affects the performance, and that will be my last aspect of this video. So let me run that as usual. I say cd, then I say to do graphical user interface, where then I use the command streamlit run, then main, it is called home not main, and then this gives me a graphical user interface. This has already existing to-dos. I can click on them to delete them, or I can add others. I say reading. Those are to-do items that I can add on by myself, and then I can say about the performance that really, if this is hosted only on my machine, you can see that it is very fast in executing. Then if it is on another machine, or different users having this web application, like I will provide the link to this application, you will see that the performance is slow when like 3 or 5 users are using this application concurrently. So that link will be provided in the description, and then you can be able to see or to use this application on your own and see how it is slow, because many users can be using it. Then another thing about performance, this is a web server that has to be running this application. Let's say it is hosted, but then it should have enough CPU or enough RAM to accommodate this concurrency, or the number of users that are executing this program. That's where the performance issues come. And then lastly, I will provide also the links to the GitHub repository where this code is written, or where I structured this code, and then we can be able to see that. So I now hope you've grasped how the program runs, and we are good to go. So I end that by saying thanks for holding on to watch this video, and I hope it's of help. So bye.